Hi everyone, in this video we're going to start the P1 revisions. Now for P1 revisions, this is basically useful for the people who are going to sit for the exam tomorrow, right? So we're going to solve every question, like every different type of questions that will come across in your exams. So in this entire file, we will actually solve the questions from indices power, simultaneous equation, then sine cosine rule with circular measures and transport like transformation translation, and then we'll start with graphs. Under graphs there are a lot of concepts involved. That means differentiation, integration, turning points, that is calculation of maximum and minimum coordinates, and then completing the square, finding the equation, then region with inequalities, and lastly intersecting point. After that there are also concepts of tangent and your normal things involved, right? All those things will be actually discussed in this entire video. So if you guys can watch this entire video in one go, I would expect that will be really helpful for all of your exams tomorrow. Since tomorrow is the exam, this will be like an entire revision for all the topics, all the formulas which are needed for the P1 exam tomorrow. Okay, so now I have already prepared one worksheet. And in this worksheet, we are going to involve with graphs, sine, cosine rule, and all the things I have stated earlier. So we're not starting with graphs. We'll start with basic integration, and then move on to graphs. Okay. So this is basic integration. We'll start solving differentiation first, and then we'll move on to integration. This is your differentiation equation that is taken from Jan 2020, question 9. Sorry, this was already written over here. So what I'll do is that I actually want to keep a one space. I actually want to keep this one space for all the things which I'm going to think important. So I'll write down the list of important things that you need to remember or memorize. So I will just write it from here. I'll start differentiation from here, and then again we'll move on to the very top to solve other integration questions also. Okay. Now this is your differentiation question. Now in differentiation, always remember the format. In differentiation, what you do is that you have x to the power of n. In order to differentiate this, we'll take that power in front. It will be multiplied with x, and the power always becomes minus 1. Okay, there will be always minus 1 from the power. So now we'll start. Another thing over here to remember is that whenever you're going to given with this integration questions, right? If the integration question have this kind of format, that means the equation is not in a straight line, the equation has fractions involved, you cannot integrate this with simple integration and differentiation. What you have to do is that you have to take this differentiation denominator to the numerator, up at the numerator, so that everything is in one line, or at least there is no x in the denominator. That is the main reason that you have to take this to the upward, because I don't want any x in the denominator now. So then after that, taking all the x from the denominator to the numerator, after that I can start with my differentiation process. So at first we need to simplify that equation then, right? So we'll start with that, simplifying the differentiation equation. So y is equals to 4x square. It will be separately divided by 2 root x, and then it will be again separately divided by 9 over 2 root x. After this, I can do one thing, is that this 4 will cancel each other out. So it will be 2. And whenever same thing that in divided format, power becomes negative, like power has to be subtracted from each other. And if the x's were added multiplied together, then you would have to subtract the power, right? So over here, I would just have to subtract the power 2 minus half, because root obviously indicates half. And then you have 9 over 2. I'm going to take this root to the numerator, so it will be negative half. These are all the rules from indices, that when same bases are multiplied, their powers will be added together. When same bases are divided, their powers will be subtracted from each other. And then whenever there is a power in the denominator and we're taking that from the denominator to the numerator, the power becomes negative. That's what is happening over here. You have this root x, x to the power of half in the denominator, and we're taking this root x. When you're taking this root x to the numerator, this power over here becomes negative. Okay, so now we'll start with the normal differentiation process. That is the dy by dx. This half, wait 1 minute, there's also another step left. 2 minus half will leave you with 3 by 2 plus 9 over 2 x to the power of negative half. Okay, now I can differentiate the equation. So you have this 3 by 2 power, right? It will come in front and get multiplied with 2, and the new power will be 3 by 2 minus 1, right? Yeah, 3 by 2 minus 1. And then again, this negative half will come in front and will be multiplied with 2, and this becomes minus half minus 1. So after this point, this one actually becomes 2 and 2 gets cancelled out. It will be left out with 3. 3 by 2 is actually 1.5. So 1.5 minus 1 gives you half. So this will be positive half. And this over here becomes negative. Minus and plus will leave you to be negative. So half multiplied with 9 over 2 actually gives you 9 by 4. So it will be 9 over 4. X to the power of minus half minus 1 will give you, I think, minus 1.5. Yeah, minus 1.5, which is 3 by 2. Sorry, 3 by 2. Now this was not in the question, that they only want to find out the expression for the differentiation. They also want to find out the x coordinate when the curve's gradient or curve's equation, differentiated equation, is equals to 0. Always one thing to remember over here is that on a curve, right, if there are turning points, right, this maximum point is one of the turning point, this minimum point is one of the turning points. Always remember that for one specific graph, the equation of gradient is same. That means the one you got over here, 3x half and then 9 by 4x to the power of negative half, 3 by 2, this is the equation for your gradient, and it will remain the same for all the cases. Okay, this is the equation for your gradient, even though it was not needed in the question, but obviously I'm explaining the basics of all the concepts related for P1, so I'm just going to explain a few more things extra from every question. So now over here, this was the equation for your gradient. Always remember that the equation for your gradient will always remain same for all the points. Only if you want to find out the gradient for this point, you will just have to input the x coordinate for this point into the equation for gradient. If you want to find out the equation gradient for this point, you just have to input the value for x coordinate for this point into the equation for your gradient. So equation remains same, only the value of x changes depending on what point you want to calculate the gradient from. And there is another one thing to remember, that all on this maximum and minimum point, your gradient is always 0. On this turning point, your gradient will always be 0. Okay, dy by dx is always going to be 0. The value of your gradient is always going to be 0 at turning points. Okay, now we will start with our maths. We want to find out the y value for x coordinate when this differentiation equation was equals to 0. That means over here, I'll just keep it to the right over here. This will be entirely equals to 0. And another thing to remember is that this is x to the power of half. I'll take this minus 9 by 4 to the right hand side. So it will be 9x to the power of, sorry, 9 by 4. Sorry, 9 by 4. Now since you have a negative power over here, which obviously indirectly indicates you that this power does not belong to the numerator. This actually belongs to the denominator. So I'll just write it down over here, 3 over 2. Now if I just take this 4, 3 over 2 to the left hand side, it will be multiplied. So now you have 3 x to the power of half multiplied with 4 x to the power of 3 by 2 is equals to 9. Okay. Now again after this what happens? 3 and 4 can be multiplied together easily, which will be 12, and half plus 1. Whenever two bases are multiplied, their powers are added together, right? So it will be half plus 1. I'll just write half plus, so half plus 1, not half plus 3 over 2 is equals to 9. So you get x to the power of 2. If you take that 12 to the right hand side, it will be 9 over 12, which is basically 3 over 4. Yeah, 3 over 4. After this, I'll have to calculate the value for x. So I'll take that square to the right hand side. So now it will be 3 over 4, everything inside a root. Now always remember, whenever root breaks out, right, it will be either positive 3 over root, or it could be negative 3 over 4 root. The problem is which one will I will accept. If you go back to the question, it was already stated in the question that your value of x must be greater than 0, which indirectly indicates that x must be positive. So over here, we cannot possibly accept this data because over here x is less than 0 and we were looking for x is greater than 0. So we're not going to accept the 3 over 4 root negative, we're only going to accept the positive value. Now, the question is done. Up to this much, that's what the question was asking you from. Sorry. That's what the question was asking you from, 3 over 4 root. But if in some cases, they might also want to find out the value for y coordinate for this point, how would you calculate that? Now this is an extra, so I'll write this in red colors. In order to find out the y coordinate for this point, right, whenever the value for your gradient was 0, if you want to find out the value for y coordinate, you just have to input this value for x that you got from the previous part into your original y equation. This was your original y equation. So what will I do? I will just input that value for x is equals to 3 over 4 root into this equation, and that will give you the y coordinate for that specific point. So this is it. We'll now start with 3x to the power of negative half. I think it was plus 9 by 2 x to the power of negative. I don't remember the question. 1 minute. 3 by 2 and oh sorry, wait. Um, the question was actually 2 x to the power of 3 by 2, 9 x to the power of half. 9 by 2, right? Yeah, 9 by 2. Sorry, 9 by 2 x to the power of half. Now I will just input the x coordinate 3 over 4 root, and that would give you 2 3 over 4 inside a root, and that will be again with the power of 3 by 2 plus 9 by 2 3 over 4 root, and that will be again with the power of negative half. If you just do this on a calculator, 2 root over 3 by 4 to the power of 3 by 2, and then plus 9 by 2 with 3 by 2, sorry, with the power of negative half, sorry, the power of negative half, you're going to end up with 5.67 something value like that. Let me check again. Oh wait, sorry, I made a mistake. It's supposed to be 3 by 4. I took the other value for x as 3 by 2. Okay, yeah, now you get 6.47. Okay, so that means 6.47. Even though this is an extra, but if you were asked to calculate the y coordinate, this is how you would have calculated. That means at point 3 over 4 root and 6.45, this is the point where the value for your gradient dy by dx was actually equals to 0, right? And yeah, this is how you're going to solve all the differentiation questions actually. You can see that what we did over there, we'll obviously first have to simplify your equation. If it is not in one straight line, you have to simplify it and take all your x's in one line, or take all your x's in the numerator. After that, you differentiate with the rule. Everything, a power comes in front, and every power has to be subtracted by 1, right? After that, it was already given that dy by dx is equals to 0. So we took the equation for the gradient, we took the equation for the dy by dx, and make it equal to 0. And from there, we got the value for x. If the question would have asked you to calculate the y coordinate for this specific point, I would have inputted this value for x into the original equation for y to get the value for that coordinate. Okay, or y coordinate for that point. Okay, now this is it for the overall maths for differentiation, and this was taken from your Jan 2020. Okay, one thing over here, we understood that for differentiation integration, nothing can be in the denominator, like no x can be in the denominator, every x has to be in the numerator. So let me just write it down as a rules over here at the front, so that at the end of this entire video we can go through this as a review. First rule we got is that in differentiation and integration, there should be no there should be no value of x into the denominator. Okay, okay, and that is the first rule we got for differentiation. And that is the case for all integration also. Okay, so let's start with integration now. Okay, okay, now for integration, we have this equation. And again, as I've stated already, that there could be no x in the denominator. Now we can see it x in the denominator, right? So I'll obviously have to simplify it first. So it will be 8 over 3 x cube. And now it will be 1 over 2. The root x was at the denominator with 2, beside 2. I'll just take that root x to the numerator. So now it will be beside 1. Another thing, Now the numerator, now as it is taken from the denominator, it will have a minus power. So there's no point of writing 1 over here, because now we have a constant, a variable for x equals to x with the power of negative half on the numerator. And again, this will be subtracted by minus 1, and you have to subtract, you have to differentiate, integrate. You have to integrate this equation now. So we'll start integrating. For integration, the format is like this. If your original statement was in this format, x to the power of n, it will be now x to the power of n plus 1 divided by n plus 1, right? This is how your actual fraction would look like. After this, we'll then again move on. 8, 3 plus 1, originally it was like divided by 3, right? Now it will be again multiplied with 4. The denominator will be multiplied with 4 because you have this 3 plus 1 over here. Okay, after that, x to the power of negative half plus 1, and then again 2 will be half plus 1 is positive half, so it will be multiplied with half. Remember, we divide with the new power over here. Okay, whatever the power you get after adding 1, we're going to divide every fraction with that power. Okay, new power. Another thing, in differentiation, if you have any constant, it entirely vanishes. But in integration, if you have a constant, it will be 5x this time. Another thing, there should be a plus c. For integration, always there should be a plus c. Okay, now after this, what happens if you simplify it? This get subtracted with this, so we have now 2 x to the power of 4. This entire thing will be cancelled out because 2 multiplied with half is just 1. So you get minus x to the power of half, then minus 5x plus c. This is your equation that you get after integrating the original equation. And that is the end for your normal integration. This was taken from Jan 2020, question 1. Okay, so this is it. Now we'll move on to the next equation for integration, that is this one. Okay, now over here, if you focus on the question, it says that a curve with equation y is equals to fx passes through the point 9, 1, 9 and 10, and given that this is the f prime equation, always remember, if your equation is written in form of y, then your differentiated equation will be written in form of dy by dx. But if your equation is written in form of fx, then your differentiated equation will be written in form of f prime x. So this over here gives you the differentiated equation. F prime x is your differentiated equation. Another thing to remember, now from this differentiated equation, they want to find out the original equation. So how can you find that? There is one statement that we will have to write over here. Let me just write this over here, that in case for differentiation, this is the format. And another thing, if you're going to differentiate any constant number that doesn't have any x involved, it will be 0. And for integration of this will actually be x n plus 1 divided by n plus 1. We're going to divide that entire term with the new power. And if there is any constant over here, that's 2 dx, answer would actually be 2x. So for the constant, for the differentiation, constant becomes 0. For integration, constant is multiplied with 1x. Okay, now with your main part. For fourth part, always remember that if y is equals to fx is your original equation, then your dy by dx, which is your differentiated equation, will be written as f prime x. This is your differentiated equation. After this, if you want to somehow, in some cases, want to go back to your original equation from this differentiated equation, what you would have to do is that fx is basically integration of f prime x. If you can integrate your differentiated equation, you can go back to your original equation. But always remember, this comes with a c, right? By integrating, it always comes with a c. So you'd also have to calculate the value for that constant c. Why does it have that c? Because when you start from the original equation and differentiate it from the original equation, if it does have a constant, in some cases that constant will be entirely vanished for the differentiated equation. So yes, you can go back to the original equation, but that thing that is lost from the equation, you cannot recover that, right? So with respect to that whatever was lost from the equation during differentiation, we're going to write a C over here, that whatever constant was lost, we can calculate that, or there was something constant in the equation which was lost during differentiation, and we write C with respect to that constant. Okay, now let's move on to your next integration question. This is your integration question. Okay, as I've already stated that yes, if you can differentiate it, that will give you your original equation. So if you can integrate it, that will give you original equation. So we'll start with the integration first. But again, I need to simplify it. As you have f prime x, that would actually be 27x squared minus 21x to the power of 3, 2x to the power of half, and then plus 5x 2x to the power of half, right? We are going to plus over here because this entire fraction was with minus, right? So minus minus, eventually that 5x becomes positive. Okay, now if I simplify it, 2x to the power of 2, this is going to be 21 divided by 2. What do you get? 3 minus half. You're going to get 5 by 2, right? So I'll just directly write it down as 5 over 2. And for this part, 5 over 2 x to the power of 1 minus half. That will be just minus half. So positive half in that case. Positive half. From this part, from this part onwards, I can do the integration now, because now all of my x is in the denominator, so it's in the numerator, right? There is no x in the numerator, so now I can integrate it easily. Okay, so now for the integration process, this is how the entire thing will start. You have 27x to the power of 2 plus 1 divided by 2 plus 1 minus 21x to the power of 5 by 2 plus 1. Then this will be multiplied with 5 by 2 plus 1. And over here you have this 5x to the power of half plus 1, half plus 1. And there will be a constant C over here, right? Later on, I'll tell you how to calculate the value for constant C also. So if you just simplify this at first, 2 plus 3 is, 2 plus 1 is 3, so 27 over 3 will give you 9. So it will be 9x to the power of 3. And then you have this 5 by 2, right? So 2 multiplied with 5 by 2 plus 1, it should be 7. So 20, again, that 21 divided by 7 should give you 3. So this is minus 3 x to the power of 3 by 2, right? If I'm not wrong, 2.5 plus 1, yeah, 3 by 2. And over here also you have 5 divided by 0.5 plus 1, which is 10 by 3. Okay, so now you get positive 10 by 3 x to the power of 3 by 2 plus c. Let me see if I'm making any mistake. No. There was this 2 already involved with this, right? Because as you can see, it was 5 by 2 x to the power of half. So 5 by 2, this was half plus 1. Half plus 1 will be multiplied with 2. Right, sorry, made a mistake. So it will actually be 5 by 3 over here. Right, this one is supposed to be 5 by 3, and 0.5 plus 1 is 3. Okay, now this is correct. Okay, now after this they want to find out the full equation for the original equation, right? Now this is not the equation. I mean, the original equation would not have a constant, it has a value. How can you calculate that? Now this point will play a role in cases when you want to go back to the original equation from the differentiated equation by integration. They will always give you one point like this. This is your one point, that point 9 and 10. So now in this equation, I'll write the equation for the last time in a proper way, that your y is equals to 9x to the power of 3, 9x to the power of, 3x to the power of 3 by 2 plus 5 by 3x to the power of 3 by 2 plus c. Now whenever you get places for x and y, I will just substitute that with 9 and 10. I can clearly understand. There will be, I'll have 9. All these cases I'll input with 9, and over I'll input it with 10. So now I can write, instead of writing y, I can write 10 is equals to 9 power 3 minus 3, 9 power 3 by 2 plus 5 by 3, 9 power 3 by 2 plus c. right? 3 by 2, 3 by 2. Wait, I think 2.5 plus 1 is, this is actually 7 by 5. 3.5 this is. So you made a mistake. 7 by 5. Let me check if I'm making any mistake anymore. 2, 3.5. No, that was 3. Over here, this will also be 7 by 5. Just 1 minute. My tab is updating all of a sudden. Uh, yeah. Okay, so it will be 7 over 5. Hmm. Yeah, other than that, there will be no other changes. 3 plus 1 is 2, 7 over 5, and that will be 1.5, right? No other changes that will be included. So now you have, I'll just calculate all these things on the right hand side together first. 9 with 9 cube multiplied minus 3 with 9 to the power of 7 by 5, which you can also write as 3.5, that's totally fine, plus 5 by 3 with 9 to the power of 1.5. So wait, the value for x was 9, so 5 by 3 plus c is 5.2. 1 minus half is going to be half. You get half plus 1, half plus 1. Yeah, wait 1 minute. Over here from this part, if you calculate, you're going to get the value for c as into decimals. But I don't think that should be correct over here. 1 minute. 327 divided by 2 plus 1, that's 3, that's going to be 9. 9x to the power of 3, then 21 divided by 2, 2.5 plus 1, that is going to be 3, so 2.5 plus 1 is actually 7 by 2. Sorry, this is 7 by 2, not 7 by 5. 7 by 2. Okay, now I think I'm going to get a perfect solid value for 9 for C. So the value over here you're going to get is 10 is equals to 45 plus C. So you want to find out the value for C, it's going to be 10 minus 45. 10 minus 45 is going to be minus 35. So minus 35. In that case, now we can write the final equation that fx, original equation was 9x cube minus 3x to the power of 7 by 2 plus 5 by 3 x to the power of 3 by 2 minus 35, right? This is your original equation. Let me just highlight this with the highlighter. This is how the original equation would look like. So now again, let me tell you what we're supposed to do when we would have to calculate the original equation from the differentiated equation. So we will start with the differentiated equation, we'll simplify it, then we will integrate it. After the integration, we would have got the final equation, but final original equation for the curve, but it comes with a c, right? So in order to remove that c, they will always provide you one coordinate point with x and y both. So I'll just input that x coordinate wherever we have x in our equation and input that y into the place for y. And after that, I'll just simplify, make c the subject of that equation to get the value for c. And for the last part again, I'll write the equation for the original equation. And instead of writing c, now I'll write the value for c. And that is the final answer over here. I'll just zoom out so you guys can have a look over here. Okay, with this, our basic integration maths comes to ends. Now we'll move on to your graphs part. Okay, graphs part is very important, and in integration and differentiation will be again related for your graphs. So let's start with that. I hope integration and differentiation so far was clear for all of you. We will move on to graphs. Again, as I've already stated, this question is like this entire video will be quite lengthy because I'm going to solve all the basics of the things you need for P1. So quite lengthy, I would say. Then we're going to start with graphs. First question is from June 2020, part 3. As I go along, I'll obviously explain what we are supposed to calculate and how we're supposed to calculate. So I'll just zoom out so I can take a screenshot of this and move on to my other PDF. Just 1 minute. Okay, so we are starting with graphs. Sorry. Now in the first graph, I can see this is a quadratic graph. Another thing I can see this is a positive quadratic graph or happy quadratic graph or minimum point quadratic graph. This is the minimum point, right? Okay, now it says that figure 1 shows a curve with equation x squared plus 3x plus 3 where there was a point 316 lies on the curve. We need to find the gradient of the tangent to the curve at that point. Always remember there are going to be two things involved, gradient and normal. Okay, let me just draw a visual representation of how gradient and normal would look like. If I'm going to draw a graph over here, tangent will only meet the curve at one point, whereas normal would meet the curve at multiple points. Okay, this is your tangent. As you can see, this one is only meeting your curve at one point. That means this is your tangent. Okay, and another thing to remember, the tangent is always parallel to your curve. So whenever something is parallel to your curve, they would have the same gradient. So that means gradient for tangent and gradient for, sorry, I'll just write gradient for tangent, gradient for curve is always equal. Okay, they're always equal to each other. Whatever the gradient for curve is for that point, then the gradient for that tangent would also be same for this specific point. Okay, this point. And as you can see, this is your normal where it cuts the curve at multiple points. This is your normal. Another thing to remember for normal, normal is always perpendicular to your curve. Okay, so if normal is perpendicular to your curve, in that case, gradient for normal and gradient for curve, like the product is going to be -1. Whenever you have two perpendicular lines, this is the formula that two perpendicular lines gradient is equals to 1 minus 1, and whenever you have parallel lines gradient are always equal. This is very important diagram over here. So I'll just like write it at the very top when I was writing that rules over there at the very starting top page. Right, this one. I don't think I have enough space. I think I'll have to draw another space for this. Okay, this is the fifth point where we wrote about normal and about tangent. Sorry, 1 minute. Okay, now we'll move on to this question where it was already stated that where we need to find out the value for like the equation for the tangent maybe. Sorry, right, as we were over here. Now they have given you an equation for the curve and they wanted to find out the equation like the gradient for tangent. Okay, for the gradient of tangent, I'll start with this equation for the curve. So I will extract the gradient from tangent from the equation for curve. So we'll first find out the dy by dx, dy by dx. Now the original equation was what? X square. So it would be 2 will come in front. So 2x, 2 minus 1 will just 1. Okay, so just write 2x over here. And then we have 3x to the power of 1 obviously over here. So that 1 will come in front multiplied with what? 3. So it will be just 3 and 1 minus 1 is just 0. So you get 3 over here. Now this is the equation for your gradient. So gradient equation. Now I've already stated that for a curve, the equation for gradient will remain same, only the value for your x coordinate will change, and that will give you the value for your gradient, different values for gradient for different coordinates. Now it was already stated, I specifically want to find out the gradient at point x equals to 3. So I'll just input the value for x equals to 3 into equation for gradient. So dy by dx actually becomes 2, 3 plus 3, which is 6 plus 3 is 9. That is the equation, like that is the gradient for your curve when x equals to 3. And now I want to find out the equation for my tangent at x equals to 3. So this is quite easy. I hope all of you already got the idea. Now I'll just write the tangent parallel to curve. That means the gradient for your tangent should be equals to your gradient for curve, which means the gradient for tangent is going to be equals to 9 because the gradient for your curve was 9 at point P equals to 3. So that means this is the final answer, right? That is it. Nothing else other than that is required for your calculations. I'll just write it down over here, right? Like this. This is, I think it was better on the other side. Right, I'll just keep it like this. Okay, now this was the working for part A where you would want to find out the equation for your tangent. Okay, so gradient for your tangent. And again, after that, it says that the point the point Q with x coordinate 3 plus h also lies on the curve. Find in terms of h the gradient of the line PQ, and we need to write your answer in this format. Okay, 3 plus h. Now this is the x coordinate, right? In order to find out the gradient for two specific point, there's another different equation available. Like in order to calculate gradient, actually, there are two equations overall. The equations are, let me just write the formula again over here, 5. In order to calculate gradient, we can do one of the two procedures. First one is dy by dx, right? And then input the value of x into this equation. Dy by dx, then input x. Input x into the equation to get the value for the gradient at that specific point. There is another format to calculate gradient that is specifically for a straight line. This differentiation value can also be used for straight line, can also be used for curves, quadratic, cubic, in any cases. Okay, so for all cases, this is the situation, this is the formula that you can use for straight line, curve, a cubic graph, quadratic graph, any kind of graph, fraction graphs, anything. And the other equation is y2 minus y1 divided by x2 minus x1, and that is only a situation for straight line. That means if there is a straight line, only you can use this formula for straight line equations. Okay, now in your part B, if you remember, we were solving this graphs part 1 equation. Not here, yeah, this one, right? Over here, we want to find out the gradient of the line PQ. That means obviously this is a straight line. For a straight line over here, we are going to first find out the value for y coordinate for the point Q. So we can find out the y coordinate by inputting the x coordinate into the value for your equation, right? So for part B, we are going to start with when x is equals to 3 plus h, y will be x square. It was the equation x squared 3x plus 2. So it will be 3 plus h whole square plus 3 plus h plus 2. If I remember, this was the original equation, right? Now I'll have to simplify this. I'll simplify that 3 plus h whole square with the equation of 9 plus 6h plus h square plus 9 plus 3h plus 2. That means over here we're going to have h square. This is going to be 6 plus 3 is 9h, and there's 9 plus 9 is 18 plus 2 is 20. So this is 20. So that is the value for the y coordinate of point Q. Now I'll write the coordinates of P and Q again. P was, I think it was, I don't remember, 3 and 9, right? Okay, so 3 and 16. Okay, so 3, 16, and for point Q it was h square plus 9h plus 20. H square plus 9h plus 20. Okay, now after this I can find out the gradient between the point PQ. I will consider this as x1, y1, this as x2, sorry, Forgot to write the x coordinate over here, which was actually 3 plus h. 1 minute. So over here I can write y2 minus y1 divided by x2 minus x1. So now you have already seen this is your x2, y1 by the way. So y2. And I can already see on your y2 we are going to write h square, 3h, so 9h, so 6h I think it was. No, 9h, 3 plus, yeah, okay, sorry, it becomes 9h plus 20 minus 16 was your value for y2, and then you have 3 plus h minus 3, that was the value for your x1. Now after this I can clearly understand it will be h square plus 9h plus 4 divided by just h, right? Yeah, that was the gradient for the line PQ. I don't think I can simplify it more. 1 minute. Let me see if I can middle term, if I can factorize the numerator. 1, 9, 4. Yeah, I cannot factorize it. It has to be broken down in terms of middle term formula method. Okay, so that is it, the equation for your gradient for the line PQ. In terms of h, the gradient of the line PQ, 3 plus h, let me see if I made any mistake. 9, 2, 3, h, 6, and then h squared, then it becomes 3 into 3 is 9, and then 3h plus 2, so you get h squared, 3, 6 is 9, and then 9, 9, 2 is 20. So you subtracted it, h squared, 9h, 20, minus 16, and 3 plus h minus 3 is going to be h. Yeah, that is it, the equation for the gradient of the line. This is the gradient for the line. We want to find out the gradient, right? And this is it. Other than that, nothing has to be calculated after this. That was the entire working for part B. Okay, after this, for part C, they want to explain briefly the relationship between your answer B and to your answer A. Okay, since there is a relationship, I think there must be something wrong that I did. Since they're asking about relationships over here, that means in some cases I can get I think now we have to use that limiting factor for your equation for the straight line. For example, over here, for this case, if I'm going to take for part C, if I'm going to take the value for h as greater than or equal to 0, that means a value for h can be also 0, right? If the value for h is 0, wait, no, if the value for h is 0, then it becomes h plus 9. No, I cannot take that. Wait 1 minute. 9h square plus 9h plus 4. I'm not sure if I'm making any mistake. 3 plus h whole square plus 3 plus h, which is 3 to 3 is 9, 3h plus 2. So you get h square, 9h, 20. Find in terms of it the gradient of the line. PQ, write your answer in the simplest format, right? I got the gradient of the tangent T as 9. But over here there's no similarity in between my part B and A. H square 9h plus 20 minus 16, 3h plus 3 plus h minus 3 is actually h, right? That is, up to this there's no problem. I think I made a mistake during the calculation while reading the question, right? Over here it was minus 2, sorry. So in that case, if this is minus 2, if this is minus 2, so this is going to be plus 16 over here. Really sorry, if this is 16, in that case, this is 16, this is 16, minus 16. Obviously, you can see 16 and 16 will be cancelled out. And now we are left out with this h square plus 9h divided by h, right? After this, we are going to start with, I can take that h common from the numerator. So it will be h plus 9 divided by h, right? So h just gets cancelled out. You get 9 plus h. at the end. The gradient for the line PQ was 9 plus h. Now you need to find out the relationship between part A and B. On part A, you calculate the gradient for tangent, which came out to be just 9, and this is your working for part A. And for part B, you calculate the gradient for PQ, so M for PQ, which came out to be 9 plus h, right? If you remember the derivation of the differentiation over there, you had this point that h can be greater than equals to 0, right? If the value for h is 0, if you're going to consider the gradient of PQ where h is greater than 0, so you get 9 plus 0, which is 9. In that case, you can say that the gradient for PQ is 9, which was the gradient for tangent also. That means the final relationship over here is actually they have equal gradient, and whenever two lines have equal gradient, this indicates their relationship will be they are parallel, right? Their relationship over here indicates that the line PQ is parallel to the tangent of the curve at specifically point P, tangent at point P. This is the relationship, that line PQ is parallel to the tangent at point P. Tangent at point P, right? That is the relationship that they were asking about. And yes, this is the first graph equation. As we will do more graphs in the video, I think it will be clear for all of you to understand this. So this was the first equation, which was taken from your Jan 2020 graph. So Jan 2020 question number 3. So we'll move on to your next part. So we are done with this equation. Then let's move on to the next equation. This is from again Jan 2020 question 6. Okay, now for this question over here, it says that we have a line 1 with equation this, and again it says that line 2 cuts the x-axis at point R and is also parallel to the first line. We need to find the equation for line 2 and write your answer in this format. Okay, now over here let me tell you that in order to find the equation for a straight line, there are 2 points. There are 2 methods you can follow. Okay, I should have written down on this space, but I don't think I have much space over here left. Right, these are all the formulas I was supposed to collect. So I think I will actually open a different file. Okay, so then I guess, oh wait, I cannot open a file. 1 minute. Right, this is where I'll write all the rules for your P1. I think, wait. I cannot open 2 files at a time. So this is quite problematic. Wait 1 minute. Okay, so I'll just write down that 6th formula I was supposed to write. So this is going to be the 7th formula now. This was just 6th formula. Okay, so with the 7th formula, I'll tell you the 2 different methods that you can follow to calculate the equation for a straight line. Okay. This is the continued version of that formula. This is the 7th formula or 7th rule. That is, in order to calculate the equation for a straight line, this is the first formula that you can use. If you are given with one gradient, I mean the gradient of the straight line, and one coordinate, which is basically m, and this is x and y, then you're going to use the equation for y minus y1 is equals to m x minus x1. Right, this is the equation you're going to use if you are provided with one gradient, one coordinate. And another format is that if you are given with just 2 coordinates, that means either x1, y1 or x2, y2, then you can use this equation also, y minus y1 divided by y2 minus y1 is equals to x minus x1 divided by x2 minus x1. This is the formula that you can use again. So these are the two formulas that you can follow in order to calculate the equation for a straight line. Now let's go back to the question again. In the question, you were provided with one coordinate. You want to find out the equation for a straight line, right? So you're provided with only one coordinate. That means I already got the idea. Now I can calculate the gradient for this point and input that into as the equation for L2, because it is already stated that L1 and L2 were parallel to each other. If two lines are parallel, in that case they have the same gradient. Okay. Yeah, that is it. Yeah, there's no other way we can calculate that. Yeah, okay. So we're going to start with your answer. This was an extra rule, so we're going to start with the answer over here. At first, from line 1, okay, we'll start with from line L1. The equation for L1 was what? 3x minus 4y plus 20 equals to 0. It has to be rearranged. So it will actually be 3x minus 4y plus 20. I will just make y the subject. So it will be 3x plus 20 is equals to 4y, and take that 4 to the left hand side and flip it. So it will be 3x plus 20 divided by 4. If I divide both terms separately with 4, this is how the equation would look like. Y 3 by 4x and 20 by 4 is just 5. So you get 5 over here. Now this was the equation for a straight line 1 in a simplified format. Let's start from here. After this, we'll start differentiating it, like calculate the gradient for line 1. So gradient for line 1 is actually dy by dx. Right, so if you dy by dx over here, it will only be 3 by 4 because 5 will entirely vanish. Now again, I already know that your line 2 is parallel to line 1, which gives me the idea that they must have the same gradient, which means that m2 must be equals to m1. At this part, I can understand gradient for m2 is actually equals to 3 by 4. Now, in order to find out the equation for a straight line, I have one gradient and one coordinate, which was 8 and 0. Now, in order to find out the equation for straight line L2, this is the equation I can use, y minus y2, y minus y1, amx minus x1. Right, so let's write it down over here. So equation for straight line, that will be y minus y2 m x minus x2. That would be y minus y2 was what? 0, right? Not y2, sorry. This is x1 and y1 and x1. So you get 3 over 4 x minus 8. That would be y 3 minus 3 by 4x, and that would be 6, I think, if I'm not wrong. Let me just calculate it. Yeah, minus 6. So that is the equation for your line L2. Final answer for part A. Right, this is how you're going to calculate the equation for second line if it is parallel with the first line, where the equation for the first line was given and only 1 point for that line 2 was given. Okay, now after this we'll move on to the second part. This one is done. For second part, it says that line 1 cuts the x-axis at P and y-axis at Q. Given that this PQRS is a parallelogram, find the area of this. Okay, let's just find out the values for P and Q. R is already given, but S is not given, but we cannot calculate S also because that is the working for your part C. We cannot solve one thing in the previous section even though you need it, right? You can only solve it when you are asked to solve it in that part. Okay, so we'll start with this, that for part B, it was stated that line 1 crosses the x-axis at point P. At x-axis, y is always 0. So you can write y is 0. If the value for y is 0, this is going to be 3 by 4x plus 20 So I think this is plus 5. This was the equation for line 1, if you remember, after it was simplified. So now it will be 3 by 4x equals to minus 5 because y is 0. So this will again be what? Minus 20 by 3. So that means point P has a coordinate of minus 20 by 3 and 0 because y over here is already 0. And then again it was also stated that L1 crosses the y-axis at point Q. So at y-axis x is 0. So now you can write y 3 by 4, 0 plus 5. So which will just be 5 over here. And from this part we can write Q is actually 0 and 5. Now let's just draw a visual diagram. For example, what is exactly 20 by 3 in decimals? Let me see. This is 6.67 approximately, negative. Let me see, just go back to the question once more. Cuts the x-axis at P, cuts the y-axis at Q. Okay, so let's just draw a visual diagram, like how they would represent on a graph. It was already stated R was 8 and 0. Okay, just a simple sketch, nothing to be very specific with coordinates. Okay, now I already know R was on the x-axis. I'm considering this as 0.8. Okay, this is 0.8. Q was on the y-axis. I'm considering this as 0.5. This is 5, this is 8, and P was on x-axis again, but it was at 6.67. 20 by 3, 6.67. So I'm considering this as 6.67, which is negative 20 by 3. Now if I want to create a parallelogram with all these lines, I'll have to connect these and this. And where would possibly S situated over here? This is your, by the way, point R, this is your point Q, and this is your point P. That means S over here must be situated somewhere in this part, somewhere in this axis, right, in the negative axis. So not exactly in the negative axis. If it is a parallelogram, in that case, exactly over here. Like these lines should be equal to each other. Parallelogram means opposite lengths are parallel to each other, right? So this is how the entire thing would look like. Now I can clearly see like this line is parallel to this line is parallel to this line. That's how it creates a parallelogram. Another thing I can understand is that this portion P, Q and S, these three creates an entire right angle triangle. I can also understand this because it was stated that, one minute, let me just highlight this section and then explain it to you again. Because it was stated that line 1 and line 2 were parallel to each other. Parallel means that they will certainly never meet at any point, and line 1 passes through the point P and Q, right? So if you remember that, this is where the line 1 must pass through. This is where the line 1 must pass through, passing through P and Q. And it was also stated that line 2 passes through point R like this, and they were parallel to each other. This is your line 1, this is your line 2. Like all the information that was given in the question matches with the diagram. Now in order to find out the area for this parallelogram, I can clearly understand this creates a 90-degree over here, which makes this OQ the height of the entire triangle, and that PR the base of the triangle, right? And there are two triangles. This is triangle 1 and this is triangle 2. As they are parallelogram, these two triangles must be equal in area. So I can just calculate the area of the first triangle and then multiply that with 2 to get the value for the entire parallelogram. So this must be your position for X also, for S also. Okay, now not to get involved with S, we'll first find out the length for OQ and PR, because using that I can use the formula half into base into height. So let's start. Let's find out the distance. Coordinates were R were 8, 0. P was minus 20 by 3, 0. Yes. And Q was 0, 5. And origin was 0, 0, right? There's no point for origin. It's only always 0. For that QO, this is going to be what? X2 minus XQ minus X origin. whole square plus yq minus y origin whole square, everything under a root, which means just 0 minus 0 whole square plus 0 minus 5 whole square, everything under a root. This is supposed to give you 5, I think, if I'm not wrong, because everything is 0, right? 0 square plus 5 square. Yeah, answer is 5. The length for the height was 5. This is by the calculation. This is the height of that triangle that was being created inside the parallelogram PQRS. And for that length of PR, that would be just XP minus XR whole square plus YP minus YR whole square, everything under a root, which would be xp was minus 20 by 3 minus 8 whole square plus 0 minus 0 whole square, everything under a root. Plus 0. So you get 44 over 3. Now this was your base, by the way. Now using the formula half into height into base, we can find out the area of the quadrilateral. So for that area of the quadrilateral, so a parallelogram PQRS, that would be twice the triangle PQR, right? Triangle PQR, which is twice into half. Base was 44 by 3, height was 5. So you get 44 by 3 into 5 is 220 by 3. This was the area of the parallelogram. So you'd always have to write unit square as an area for a graph, area under a graph. So this is how you'll calculate this entire part. I hope this was clear for all of you. We'll move on to the last part, for part C, where they ask you to calculate the coordinate of S. Right now, the coordinate of S. For the coordinate of S, if you go back, we can clearly understand over here is that if the height, since the height of, this triangle and this triangle is equal, if the height of the triangle was OS, this is the height of the triangle of also, right? So in that case, I can only already understand that if Q was intersecting at point y is equals to 5, that means the y coordinate of point S is going to be minus 5, right? And again, since I already have the y coordinate of S is a point on L2, I can just input that y coordinate of 5 into the equation for L2 to find out the x coordinate of L2. So we'll start with that. For part D, actually, we don't need much space. I'll give some explanation which are not needed. I'll say that triangle PQR were equal to triangle PSR, which indicates that height is equal to both cases, right? Height is same. Height is same. That means the y coordinate for point S is also supposed to be 5, but in the negative direction, as S was in the negative direction, right? So S would be exactly minus 5. And also S was a point L2, which means that if S is a point on L2, that means I can say that the equation for your line L2 was what? We calculated that, I think it was y is equals to 4x at the very start. Sorry. Yeah, it was y equals to 3 by 4x minus 6. Okay. So now I can just input the value for y equals to minus 5 into that equation, since S is a coordinate of point L2, is a line for L2. So now I can write y 3 by 4 x minus 6, which will be y 3 by 4 x minus 6 equals to 0. So I'll just take that 6 on the other hand side, and that would be 6 into 4 divided by 3, that's 24 by 3. So the x coordinate is 8 in that case, right? Yeah, this is 8. So which means that point S has a coordinate of 8 minus 5. Wait, sorry, I made a mistake. The y coordinate was not 0, the y coordinate was minus 5, right? Yeah. So this will be equals to minus 5, sorry, yeah, minus 5 plus 6, that becomes positive 1. So in that case, 1 multiplied with 4 by 3 would just be 4 by 3, right? So in that case, point S has a coordinate of 4 by 3 and minus 5, right? This is the final x coordinate or s coordinate over here. Right, so with this, our entire working for question 2 ends. I mean, next question of our graphs. So we'll move on to the next part. I know it has already been 1 hour, but we still have a lot of questions to end. So we'll, as I've already stated, this is going to be a very, very lengthy lecture. So please bear with me and solve as many questions as you can. So we'll move on to the next question. Okay. Now this is taken from your Jan 2020 again, question 8. Okay. So for Jan 2020 question 8 now, 1 minute. Over here, it says that the straight line with equation y is equals to kx, where k is a constant, and there's a curve with equation this. Find the set of values for k for which L does not cross or touch C. Now this question is entirely about determinant. Determinant? Sorry, discriminant. Sorry, discriminant. Right, this question is already only written like related to the part of discriminant. Now, if you guys remember how to calculate discriminant, there were three specific graphs. If you remember, I'll just copy the axis and then draw 3 graphs. Now I'm only drawing this for positive quadratic graphs, okay? But the same can be used for negative quadratic graphs as well. Okay, now you can see that these were the intersecting points for the graph with the x-axis, right? As you can see over here, this is for 2 real distinct points. Whenever a straight line, a curve, or a curve with the x-axis intersects with each other, 2 distinct points, the discriminant become b square minus 4ac greater than 0. Whenever they intersect with one point, one real point, you find the discriminant b square minus 4ac equals to 0. And whenever there is no intersecting point, you refer to these situations as imaginary, complex, no roots, no real roots. And over here, discriminant is always less than 0. Like it always comes out to be negative, less than 0. So now over here, the question was stating that the line and this curve was not intersecting at one point, does not intersect at any point. That means the third graph over here will be in use, where the discriminant is less than 0. So let's just find out a common equation for the intersection, and then we'll use a discriminant over here less than 0. So the equations were, even though they do not intersect, you would still do the calculations for y equals to 0 and y equals to 0. You substitute the two equations together. So first equation was y k 2x minus 1. So k 2x minus 1. This was your first equation. Let me just simplify it, which will be 2kx minus k. And the second equation is actually going to be x squared 2x 11. So x squared 2x 11. This is your second equation. This is your first equation. So what will I do is that substitute the first equation into the second equation. And this will be y1 is equals to y2, which is basically x squared plus 2x plus 11. Let me just go and check once. Plus minus, right? And on the right hand side, you'll have 2kx minus k. I just take everything to the left hand side. So you have x squared plus 2x minus 2kx plus 11 minus k equals to 0. I will just take x squared. From here, I can take x common to like separately indicate that this is the equations part B, A, and C. So this is going to be 2 minus 2k x, and C constants over here is going to be 11 and k, right? That means over here from your equation, the value for A is 1, B is 2 minus 2k, and C is 11 minus k. After this point, we will now calculate the discriminant. We'll try to find out the set of range of k. That is discriminant over here, discriminant is going to be b square minus 4ac less than 0. According to this, the value for your b was 2 minus 2k whole square minus 4 1. C is 11 minus k less than 0. After this, you have what? 4. 2 into 2 into 2 is going to be 8, right? So it's just going to be 8k plus 4k square, and this is going to be 4 into 1 is just 4, right? There will be no changes for that. 4 into 11 is going to be 44, and this is going to be plus 4k less than 0. Yeah, other than that, there's no mistake. 4k square minus 8k plus 4k will leave out with 4k, and 44 plus 4 is going to be minus 40 less than 0. 4k square minus 40, right, minus 44. After this, we can clearly see this is a quadratic equation, right, where 4 can be taken as a common. But if we don't do this, what would be the final answer? 4 minus 40. Yeah, the values over here are coming out to be, if I'm going to take 4 common, just 1 minute. 1 minus 1, sorry, minus 1 minus 10. The answer is going to be actually in that formula method. So what you would have to do is that you actually need to break down the formula over here. You cannot just middle term this. Now this is equals to minus 4 plus minus root over 4 square minus 4 minus 40, everything under root. This is now divided by 2 4, right? From this part you get two values for k, which is 1 plus root 41 by 2, and the other one would be 1 minus root 41 by 2. Now remember, this was a quadratic equation less than 0. If this is a positive quadratic equation less than 0, then this is how you're going to write the inequality for it. Right, a quadratic graph, positive quadratic graph less than 0, that means this portion you are using over here, and right over here this is your value for point. Let me just find out the values. This is the minus 1 is actually negative, so this is actually positive, and the minus 1 is negative. Okay, like if you use a calculator, you will see this is giving you a 3 points positive value, and this is given negative 2.7 value. I'm going to consider this as B and this as A. So which means your A is over here and B is over here, right? So your inequality should be less than A and greater than B. As you can see, the region that I've shaded is only situated in between the range less than A greater than B. So that means I can write K is actually less than 1 plus 41 divided by 2 and greater than 1 minus 41 divided by 2. That is the ranges of values of k which you were asked to calculate. So this was your critical point. You can also write it like this, that we are trying to calculate the critical point first. So you can just write it down over here, that critical point and you can write over here as the set of values or range values. And this is the final answer over here. This is your final answer within the range of k. Okay. So this was it for the discriminant process. This is again our rule, right? So far this is your 8th rule now. Okay, this is your rule number 8. Okay, Now after this, we'll move on to our next question again. I know this is getting quite very long, but I don't have any other options. So we have solved this one, we solved this one and this one. So let's start solving the next question. This is from June 2020, question 6. Okay, now over here, this is question 6. Let's start. The point A has coordinates 4, 11 and point B has coordinates 8, 2. Find out the gradient of the line with equation at giving you answers fully simplified fractions. We can clearly understand that since they have given you two coordinates, we're going to use the equation y minus y1, y2 minus y1, x minus x1, x2 minus x1, right? I'll first write the coordinates as over here 4, 11 and 8, 2. I will consider this as x1, y1, x2, y2, right? Okay, so now for part A, I'll write the equation y minus y1, y2 minus y1, then x minus x1, x2 minus x1, which is going to be y1 is 11, x2 is 2 minus 11, and then x minus 4 minus 4, right? Yeah, this is how it will look. That means y minus 11 divided by, you get minus 9, and x plus 4, and this is also 12, right? 8 minus 1 minute, 8 minus 4 is positive 12, and 2 minus 11 is minus 9, right? So this is 12. So we take this 9 to the other hand side. Again, remember in what format they ask you to keep your answer in. Wait, sorry. They were only asking you to calculate the gradient, not the equation for the straight line. I'm so sorry. I read the question wrong. I'm so sorry. They were only asking you to calculate the gradient. So for the gradient part, it's just going to be y2 minus y1 and x2 minus x1, right? Which is just what? 2 minus 11 and then 8 minus 4, which is 9 over minus 12. Answer would be negative 3 by 4. Right, yeah, this is the final answer then. Yeah, really sorry. That was all the informations, all the things you need to do for part 1. Okay, after this, we'll move on to the next question. And for part B, it says that point M is the midpoint of MB, AB, and there's a line L passes through M and is also perpendicular to the line AB. So you need to find the equation for that line, giving your answer in the form of this, where P and Q are integers, and you have to calculate that. Okay. So now there are a few things given. Let me just write down the informations first. It was stated that that line L was perpendicular to AB. That means whatever the gradient for AB was, that will be minus 1 divided by AB will give you the gradient for that perpendicular line, right? So let's just write it like this, that M gradient for that line L and product of the gradient of line AB should be minus 1 because they were perpendicular, right? That was written in the rules, in one of the rules I've written at the very start. For the gradient of line M is then going to be 1 over gradient of AB, that is now minus 1 over minus 3 by 4, which is just going to be positive 4 by 3, right? That is the gradient for your line L. Another thing, line L passes through point M. M was the midpoint of AB. So let's just continue and calculate the coordinate for point AB, which is just going to be XA plus XB divided by 2, and then again y coordinate would be YA plus YB divided by 2. This is how you calculate the coordinate for the midpoints, which is A was minus 4 and 8, so minus 4 plus 8 divided by 2, and over here it's going to be 11 plus 1, 11 plus 2. Am I making a mistake? 11 plus 2, no. This one turns out to be 4. 4 divided by 2 is 2, and this one is 13 by 2. So this is your one coordinate. For that line L now, you have, for part B, they were only asking you to calculate the coordinate equation for line L. Now you have one coordinate and one gradient for line L. So you can clearly understand we're going to use the other equation, y minus y1 mx minus x1, that one. So I'll just take a separate section over here. For line 1, I'm going to start with the equation for line 1. For line, now you have y minus y1 m x minus x1, and that would be y1 is 13 by 2 and m is 4 by 3, x1 was 2, right, which becomes y is 4 by 3x. 4 by 3 with 2 is actually 8 by 2, I think. 4 by 3, sorry, by 3 multiplied with 2 is 8 by 3. This is negative 8 by 3, and when this 13 by 2 goes on to the right hand side, this becomes positive. So you have negative 8 by 3, sorry, negative 8 by 3 plus 13 over 2, this is 26 by 23 by 6. So the final y coordinate is 4 by 3x plus 23 by 6. That is the equation for your line y, final equation for your line y. I'll just take this a little bit up so that it's quite separate. Right. This is how the part B will actually be. I hope this one is entirely clear for all of you. We will move on to your next part, which says that the point C lies on L such that the area of the triangle ABC is 37.5. Write down the two possible coordinates of AB. Okay. Okay, so now you have AB. C lies on L over here. It was stated that C is lying on L. That means I'll just draw a sketch over here again. If this was the coordinate and this was line L, line AB, okay, and I'll just use different ink. This is your line AB, and this was your line L, which was actually perpendicular to the line AB. Now you can see this is point B, this is point A, and this is your line L. This was your point M, and it was your point C. Now it was already given to you that they were creating a triangle. Like this AC, if you connect it, and this BC, if you connect this is creating a triangle. I already can understand that this is going to be a 90 degree over here, right? That means MC is actually your height, and AB is your gradient, right? Is your base over here. So since the area of the triangle, like this is one of the possible answers, or your point C could also be over here also, right? Like this could be, or this over here could be one of the possible answers. Like their point C could be either above or below, we do not know, but that is how the overall diagram would look like. Now over here what I will do is that I already can understand that AB is the base, so I will find out the length of the base, which is what length of the base was XA plus XB whole square, so minus, plus YA minus YB whole square, everything under a root. Now from this point, if you try to calculate the area, I mean the length for AB, which is needed, this was minus 4, 11, 8 and 2. Okay, this is going to be minus 4 minus 8 whole square plus 11 minus 2 whole square, everything under a root, which is going to be 4 minus 8 square, 11 minus 2 square, this is 15. So the base over here is 15, and this is your base of the triangle, and height was CM. Okay, okay, now we can find out the area. Area would be half into base into height. We already know the area of this triangle, which will be 37.5 given. Base was 15 multiplied with cm is equals to 37.5. So if you just make cm the subject, that will be 37.5 multiplied with 2 divided by 15, which is 37.5 with 2 by 15. This gives you 5. That means the length of CM was 5 over here. Okay. So if this is 5 in that case, length is 5, right? Wait 1 minute. I think I know how to do this because I have the length from this point, the y coordinate. The y coordinate was 13 by 2 for m, right? That was 6.5 over here. Y coordinate was over here 6.5. So if you go 5 units downward, that means just subtract 5 from that. 6.5 minus 5 gives you 1.5. That means one of the possible y coordinate for C is 1.5. As I have stated that C could be below M or above M, right? So if you go 5 units upward, that would be 11.5. So the two y coordinates, possible y coordinates for C would be 11.5 or 1.5. If I go back to the question, they also wanted to find out the two possible pairs of coordinates for C, because over here they haven't mentioned that where C would actually be in the positive or in the negative or wherever it could be. That means on your diagram also over here, it should be like drawn on the axis. I should just minimize it a little bit so that I can fit everything inside. That means another possible triangle that this C could be creating was over here. Yeah, I'll just simplify this. This was your M. Now this is either this is your possible value for C or this is a possible value for C. So for that case, the y coordinate over here, possible y coordinate is going to be 5 plus or minus the coordinate of M. So it's just going to be YC. One would be 6.5 minus 5. That would be 1.5. Another would be YC is 6.5 plus 5, which would be 11.5. Now already I know that C was a point on line L, so I can just use this coordinate and input the equation in my line L to get the possible x coordinate over here. 4 by 3, 26 by 3, so which is going to be y 4 by 3x plus 23 by 6. In that case, now you have 1.5 4 by 3x plus 23 by 6. If you just make x the subject of this equation, which will be what? 1.5 minus 23 by 6, and this entire thing will be divided by 4 by 3. This should give you minus 7 by 4. And then similar working, 4 by 3x plus 23 by 6, where you will input 11.5, 4 by 3x plus 23 by 6, which will be now 11.5 minus 23 by 6 divided by 4 by 3, which gives you 23 by 4. So the possible y coordinates are either 1.5 minus 7 over 4, and the other would be 11.5 23 over 4, right? This is the possible values. Okay, now after this question ends. I hope it was clear for all of you. I'll again zoom out and I'll explain you the process. At first, we found out the gradient for AB. Using this gradient, I found out the gradient of line L, which was eventually perpendicular to the line AB. Now, after calculating the gradient for the line AB, I found out the coordinates for M, which was a midpoint for AB. This is how you'll calculate the coordinates for M. And then using the equation for straight line with one coordinate and one gradient, I will use this equation and simplify it to get the equation for your line L. After this, it was stated that it was creating a triangle ABC, where C was also a line, was also a coordinate on the line L. This was your line L, by the way. Blue vertical one is your line L. Now again, there could be two possible positions, one below and one above. So we found out the area. Like from the area, we understood this is your base and this is your height. So base was AB, so length of AB was 15 calculated. And using the area, base and half, we calculate the length for CM. Since I know that CM was 5, that means the difference between their y coordinates is going to be 5 over here, right? So if the difference between their y coordinate is 5, that means the two possible values for y coordinate would be either plus minus the y coordinate of m, which is 6.5. 6.5 minus 1 gives you 1.5 and 6.5 plus 1 gives you 11.5. Using these two possible y coordinates for point C, I'll input this into equation for that line L, as point C was also a point for line L. So using this, I'll calculate the value for the x coordinate for the two possible coordinates of point C. So this was it for all the working for this graph question. Let's move on to the next one. I don't know how many questions are left. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we're still left with 14 questions. Let's start. This is the end. We'll move on to the next question. Okay, now for question 7, it says that the curve C has equation this 1 over 2 minus x, and you need to sketch the graph of C. On your graph sketch, you should show the coordinates where any points of intersection with the coordinate axis and state clearly the equation of asymptotes. Okay, now for asymptotes, okay, now over here for the asymptotes, we can clearly understand that the equation should always be in this format. For asymptote calculation, equation should always be in this format. Y is equals to ax plus b divided by cx plus d, where the yes, horizontal asymptote should be y is equals to a by c, and the vertical asymptote should be cx plus d equals to 0. Right? This is HA represents horizontal asymptote, and VA represents vertical asymptotes. Okay. Now before that, we still need to find out the coordinates, like if this graph is going to intersect with any of the y and x coordinate. For that, we will first find out the coordinate axis, that at y-axis, the value for your x is 0, so x becomes 0. In that case, now you'll have y 1 divided by 2 minus 0, which is eventually just y is equals to half, right? Similarly, at x-axis, y is 0, so now you have 1 over 2 minus x equals to 0. So if you take this entire thing becomes math error, because this 2 minus 0 becomes multiplied with 0. So 1 becomes equals to 0, which is not possible. That means this graph will never meet the x-axis, right? It will meet the y-axis. And again, let me tell you why it never meets the x-axis. That is because your there was an asymptote along the x-axis. That's why it will not meet the x-axis at any point. Let's find out the asymptotes also. In order to calculate the asymptote, your equation should be written in this format: ax plus b, cx plus d. It's just easier to calculate your asymptote if the equation is written in that format. So now you have y is equals to 1 divided by 2 minus x, right? I will actually write this as 0x plus 1 divided by minus x plus 2. Now this is exactly in the form of y is equals to ax plus b cx minus d, right? From this part, now I can say that your vertical asymptotes or horizontal asymptotes, let's start with horizontal asymptote. Horizontal asymptotes is going to be y 0 minus 1. It was 1 and it was a and c, right? This is a, this is c. So 0 minus 1 is eventually going to be 0. So y is equals to 0 is your horizontal asymptote, and vertical asymptote is, this is going to be cx minus d, right? So cx minus d is this one, minus x plus 2 minus x plus 2 equals to 0. In that case, x is equals to 2. This is your horizontal asymptote. Now I'll draw the graph over here. It was a sketch, but obviously on the sketch you have to include these values. Your graph never crosses this positive x-axis. So y equals to 0 is exactly on x-axis, right? This is a line for y equals to 0. And there was another asymptote at x equals to 2. For asymptote, you should obviously draw the asymptotes as broken lines, but I wrote this as a solid line. I'll change it later. And this is what? Simple fraction equations, right? For fraction equations, the equations like graphs should be like this, over here and here. And another thing, it was cutting the y-axis at positive half, right? Okay, 1 minute. Yeah, this was actually a negative fraction graph. So this is how the coordinate would be. This is one of the portions. And wait, if that crosses the y-axis over here, this is how the other graph would be like. I'll just include a different diagram, different color for the graph, and the asymptote will be a broken line like this. This is your asymptote. As you can clearly see, the asymptote will never cut the graph. The graph will never cross the asymptote. The asymptotes were y equals to 0, x equals to 2, and the graph cuts the y-axis at half, right? This is how the sketch for this 1 over 2 minus x would look like. Okay, after that, again, you have the line L with equation 4x minus plus k, where k is a constant, and it is also stated that line L meets the curve at two distinct points. I hope you remember two distinct points represents the discriminant b square minus 4ac greater than 0. And using this, we need to show this equation over here. Okay, so I can clearly understand. I'll just substitute the two equations together and simplify it with the discriminant value. So for part B, it's quite easy. For part B, this is going to be the process y1 divided by 2 minus x. This is equation 1. Wait 1 minute. Let me go back to equation first. Yeah, y equals 2 minus x and 4x plus k. Okay, and the other equation was y 4x plus k. This is your second equation. After this, I can write y is equals to y, which is going to be 1, 2 minus x, so x it was, then 4x plus k. I will cross multiply it, so I have 1 on the left hand side, and then 2 minus x gets multiplied with 4x plus k, which is going to be what, 8x plus 2k minus this is 8x plus 2k, then minus 4x square minus kx. At the end, I'll take everything to the left hand side. So you have 4x square minus 8x plus kx minus 2k plus 1 0 and 4x square. this will be actually plus k minus 8x plus 1 minus 2k equals to 0. I wrote this like this so that we can clearly identify A is 4, B is k minus 8 and C is 1 minus 2k. Now I can use that concept, that discriminant, it was clearly stating that these two lines were intersecting at two distinct points. So discriminant over here is going to be b square minus 4ac greater than 0. For two distinct points, discriminant was greater than 0. So which will be k minus 8 whole square minus 1 minus 2k greater than 0, which is now what? K square 2 into 8 into k, right? This is going to be 16k plus 64. 4 into 4 is 16, so it's going to be 16 minus 16 plus 32k greater than 0. Finally, we can write k square minus 16 plus 32 is again going to be 16, I think. Minus 16 plus 32 is positive 16, and 64 minus 16 is positive 48. If I'm not wrong, this is the equation that they were asking. Yes, plus 16 plus 44 greater than 0, and after that they want to find out the range of values for k. For that range of values of k, I just have to middle term this. I can middle term this, like factorize this. That's going to be 1, 16, 48. If you factorize this, you're going to get minus 4 and minus 12. So k square plus 16k plus 48 greater than 0. Now I am skipping middle term, but middle term should always be written over here. Okay, so this is the calculation for critical point. For critical points, you got k as equals to minus 4 and k as equals to minus 12. And for that part, as this is for greater than equal to region and this was a quadratic, positive quadratic graph, this is how the graph would look like. And this was exactly on the negative graph, negative axis, right? So I'll just write this over here. This is now your negative 12. This is your negative 4. This is negative 4 and this is negative 12. And the regions that are shaded for this portion is going to be this parts, right? So that means your range of k should be greater than 4. Yeah, should be greater than 4 and less than 12. So that can be written as k greater than minus 4 and k less than minus 12, right? These are the possible range of values of k, right? So this is it, all the things we need to solve these questions. I hope it was clear for all of you. We will now move on to the next question for type of graphs. That was it. Right, we calculate the x coordinate, y coordinate, we calculated the asymptotes, vertical and horizontal. And after all these things, we plotted this on a sketch, and from that point we found out the equation for the k using that line and curve intersection points, and after that we got the range of values of k. Okay, I think I'll make a different section for this rest of the questions, so I'll stop this video over now.